So this is an example of one simplex. I can denote this one simplex just by writing V0, V1. So this is a shorthand for this particular simplex. When I write V0, V1, so we know that V0, V1 is written for this edge. And to have our, to complete our complex, we also include the vertices V0 and V1. So when we are in calling this one simplex, then zero simplexes are also included in that by default. When I write this simplex V0, V1, V2, so the triangle is filled. So when I write V0, V1, V2, then it automatically means that V0, V2 is included, V0, V1 is included, V1, V2 is included, individual V0 is also included, individual V1 is included, and individual V2 is also included. So instead of writing the whole uh, subset, I can just simply write this to denote this simplex. This is my two simplex. So these are the kind of simplices we have discussed so far, and in these simplexes we don't have uh, direction given to any of these edges. So these were unoriented simplicial complexes, but now we will talk about oriented simplicial complexes. Let's start with one simplex. So you can have this simplex something like this, V0, V1. And let's say the direction of edge is from V0 to V1. So I have given the direction from V0 to V1. Then how to denote this simplicial complex? We can denote this by V0, V1. You can also denote this same simplicial complex with V1, V0, but now we will have a minus sign over there. So we are going with the flow from source to target, then we have positive sign, but if we are going against the flow, then we have to put a minus sign over there. So these two are denoting same simplex. This is my one simplex. Both of this one and this one are denoting this simplex only. So the only difference in which you can see in these two notations is that these two adjacent vertices are reversed. The order of these two vertices is reversed. So whenever we reverse any two adjacent vertices, the sign gets flipped. So from plus we entered into minus sign. Let's take an example of two simplex. In case of two simplex, we can have something like this, V0, V1, V2. And let's say the direction is from V0 to V1, V1 to V2, and then V2 to V0. This depends on the structure of your simplex, what direction you have chosen. So how to denote this simplicial complex? Now we know that to denote this simplicial complex, I will write the two simplex notation, in which I write all these three vertices and concatenate them. So V0, V1, V2 is denoting this simplex. But also I can write v2, v1, v0, right? So how to decide the sign of this complex? So if I'm writing v0, v1, v2, we'll check, are we going with the flow? So from v0 to v1, we are with the flow. So from v0 to v1, we are with the flow. And then we are going to v1 to v2, v1 to v2. Then we are going, so you can read it like that we are going from v0 to v1, then v1 to v2, and then going back from v2 to v0. Here in this case, we are going from v2 to v1, then v1 to v0, and from v0, so you can assume it that they are connected circularly. So we are going from v0 to v2 again. So if I follow this path, v2, v1, 0, v2, then v1, then v0. So this is against the flow. This is going against the flow which we have decided for our complex. So here we will have a minus sign, but here we will have plus sign, because we are going with the flow. So v0, then v1, then v2, then v2 to v0. And one thing you can notice that to get this notation from this notation, we have reversed v0 with v2. v1 is in its own correct place, so v1 is at second place here also, and v1 is at second place here also. But we have reversed v0, we have swapped v0 with v2, and the sign got flipped. So whenever you reverse any two vertices, then the sign got flipped. And if you do that even number of times, then the sign will stay positive. But if you do such a reverse odd number of times, the sign will become negative, right? So similarly, if we have a 3 simplex in which we can have v0, v1, v2, v3, and you know that this is the visual diagram of this simplex is a tetrahedron, and if I say that this is the flow in the tetrahedron, v0 to v1, then v1 to v2, and v2 to v3, so this you have plus sign that you have decided. So if I reverse any two, let's say I reverse v0 with v1, so v1, v0, v2, v3, it will become negative. And if I am swapping v0 v1, but again I'm swapping v0 with v2, then I'll get something like this: v1, v2, v0, v3. So again one more minus sign and it will become plus. So odd number of reversal will give you a negative sign to the coefficient, and even number of will make the sign positive. The sign will stay positive. So this is how you denote your oriented simplicial complexes. When we were having unoriented simplicial complexes, there was no difference between this one and this two. There were no signs actually. There was no plus and minus sign. This one and this one were denoting the same simplicial complex when we were not having any direction here. But when we have included directions, then the order in which we are writing the vertices to denote our simplicial complex, that matters. In one particular order you may have positive coefficient, and in some other particular order which is against the flow you will have negative sign. So this is how you denote your ordered simplicial complexes.